Hello and welcome to Mastering CentOS 7 Linux video series. In this lesson, we will be looking into Introduction to RAID and its types. So first of all, what is RAID? RAID is a redundant array of independent disks. It provides a way to storing the same data across different devices to create redundancy, speed, or both. With data on multiple devices, the I/O can be better distributed and improve performance or create multiple layers of redundancy that protect against device failure. This is generally done to increase the mean time between failure on the data storage devices on a system. Redundancy increases fault tolerance, your ability to recover from the faulty device or transaction. Now let's talk about the hardware and software-based RAID. So first of all, what is hardware-based RAID? Hardware-based RAID controlled by a hardware controller. So what is software-based RAID? In this type of RAID, kernel will replace the hardware controller in configuration management of the RAID array. So no hardware is needed to control the device. Now let's talk about the RAID types. The RAID types usually used are RAID 1, 5, and 0. So first of all, what is RAID 0? This is a special type of RAID device that is designed for speed rather than redundancy or increased fault tolerance, and is more common in desktop laptops for that reason. RAID 0 writes all data to multiple disks devices as though they were a single device. This is often called striping as well. This combines the multiple storage devices into a larger single storage device, as well as it increases speed through multiple device I/O capabilities. Next is RAID 1. It referred generally as mirroring, as although two or more devices will appear to be a single device. Data that is written to one disk will be duplicated entirely on all others. So if you have two 40 gig hard disks, then you can use only 40 gig because the other 40 gig will be used for duplication of data. This greatly increases the redundancy and fault tolerance, but is generally at the expense of performance because every read and write will have to be done twice. RAID 5 will require at least 3 devices in order to implement. All the drives in the array will be used with parity data spread throughout all disks in a round-robin fashion. Parity data is derived from the data on all other devices and can be used to rebuild any of the active devices in the storage pool in the event of failure. So for example, if the third drive as shown in the diagram, which is labeled SC, if we lose it somehow, we can rebuild by inserting another device into its place based on the parity data that is contained on A, B, and D. As long as we lose one device, we can rebuild the array, so we can tolerate that failure. Now there are other RAID types as well. RAID 4, which is the same as RAID 5 except that a single device is used to store parity data. Similarly, RAID 10, called RAID 1 plus 0, combines both RAID 1 and RAID 0 advantages and redundancy into a larger storage device. RAID 5.0, called RAID 5 plus 0, like RAID 10.1.0 except that it uses RAID 5 device to build the RAID 0 portion. So that's it for the RAID storage and its types.